Here's a problem dealing with calculating the horsepower needed when an ATV is climbing a 15-degree hill at 25 meters per second. First, we calculate power equals work over time. And then we change work into force times displacement. And then we can change displacement over time into velocity, so we get power equals force times velocity. We use Newton's second law, sum of the forces equals ma, to determine what force we have. We use a free body diagram to look at our forces to know what forces to use on the left-hand side of Newton's second law. Since acceleration would be at an angle, we tip our free body diagram to get acceleration all in the x direction, which is the direction that the engine is pointing. We now have engine helping minus the resistance hurting and part of gravity hurting, so we have g cosine theta. But what angle should we use for theta? Is it 15 degrees or should we use 75 degrees? Well, 15 degrees is the angle of the hill, but we need the angle between gravity and the air resistance force, or the downhill, the x-axis. So we need to use 75 degrees. So we replace that with ma. And what's the acceleration in this case? Well, since it's going at constant 25 meters per second, acceleration is 0. So now we get engine force equals resistance force plus g cosine of our angle, and the gravity force is mg, which is 400 times 10. And we can use that and calculate 1,335 newtons for our force. We multiply that by our velocity of 25 meters per second, and we get just over 33,000 watts. But we need horsepower, so we need to do 746 watts per horsepower, and we get 447 horsepower, or 44.7 horsepower.